Let's begin our discussion of angles by defining some terms or formalizing some terms. We've discussed these before. We have a semi-infinite line, which means that this thing has a start point and just some other point here. So maybe we call this AB. And this is ray AB. We can often signify this like this, that we have done in the past. Ray AB. Okay, so if we have another ray that has the exact same start point, A, and heads off in a different direction, maybe we will call a point on this C. I'm going to have to change what I called that other point up there. I called it B, but I labeled it C. Let's call this one C, and we'll just change the label up here because this was supposed to be B. So now we have ray AC, and if we start at the same place, we can call this a vertex, and these two lines create some angle between them. Sometimes we'll label an angle with the alpha, Greek term, alpha. But in the past we were calling our angles angle BAC, which is the same thing as, let's just say alpha, angle alpha. So let's tie this in with a Cartesian coordinate system. So say we have a typical Cartesian coordinate system where we'll have the x-axis and the y-axis. So now let's start. Let's put the vertex for our ray here at the origin, 0, 0. And we'll create a ray in this direction that follows the x-axis. So this orange ray will be our initial side, and then we'll do another ray here, some angle off of this. We use the same start point as our vertex, and we could say, if you want to use some terminology, this is our terminus side, kind of like the final side, another way of looking at that. And then we have an angle in here. I called it alpha before, maybe I'll call it theta this time, another Greek letter. Get you used to some of these Greek letters. So the angle that the terminus side makes with our initial side then is some angle here. Looks like it could be like, say, 50 degrees. Again, with some more terminology, whenever we start an angle that heads from the origin and heads along the x-axis as the initial side and goes any distance, we could even go more than 90 here. We could take this angle all the way over here maybe, say, have this angle, and say this is 290 degrees. But whenever we're creating angles like this, where we have the orange line here in this initial position and we're measuring angles off of this, we call this the standard position approach to drawing angles. And we did this before, we'll do it here again. We can label these. So anything that's in this first 90 degrees is in quadrant 1. Anything over here past 90 degrees to 180 degrees is in quadrant 2. Anything down here below 180 but before we get to 270 is in quadrant 3, and quadrant 4 is this last quarter of 360 degrees. If we go all the way around, it is 360 degrees. What color would be good to go all the way around? I guess blue. So if I go all the way around, back to the start again, that's 360 degrees, or 2 pi radians. So I just mentioned radians. Let's review radians. So if I center a circle here, and let's just say for the sake of argument, this thing, if we measure the distance from the center to the outside edge, there's a distance of 1, so the radius of the circle equals 1. Then I can, if I would take a string man and I would to stretch it out here in this distance, and then I would lay it along the edge, the outside curve, and we did this already. I would have 1 radius, 2 radius, and 3 radiuses. So this length I could stretch 3 times, almost go 180 degrees, but there's a little bit left over. And that little bit left over is a distance of 0.141 dot 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 dot. Goes on forever. This distance is an irrational number. So in 180 degrees, as we spin around a circle, this equals 3.141 dot 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 times the radius. But if the radius equals 1, it's times 1 equals 3.14 equals pi. I guess I'll put the radius in, equals pi r. So if r equals 1, then 180 degrees equals pi radians. 360 is 2 pi radians, like I just mentioned up above. And that's a conversion factor we can use for degrees to radians. Radians are useful in mathematical calculations. Degrees are useful in like graphical representations. So if this is half a circle, circumference, then 360 degrees, twice of this, 2 times 180, 2 times equals 2 pi. 2 pi. So going all the way around is 2 pi. This is just the circumference of circle. So when we express our angles in degrees or radians, these are our conversion factors between angles and radians. So if that's the case, let's look at some important angles in a circle. Okay, so we know then that if there's 360 degrees in a circle, that if I go a quarter of the way, that's 360 divided by 4, or 90 degrees. So if that's 90 degrees, if I were to cut this in half, so after moving half the distance then to that y-axis, so if I've got an angle and I'm heading in this direction with this angle, and I move half the distance, we know that this is 45 degrees. If I continue on, this is 90 degrees. And then I go 45 degrees more. This will be 135 degrees. And then 45 degrees more. This is 180 degrees, so on and so forth. Then 45 degrees more. This is 225 degrees. And then 45 degrees more. This is 270 degrees, so on and so forth, going around here. 315 degrees, back to 0 degrees, or 360 degrees. Same thing. Alright, so now think about this. If I were to take an angle that goes all the way over to here, that's 180 degrees. But we know that that was equal to pi radians. But we see we split this up into 4 equal angles. So pi divided by 4 is the number of radians then in 45 degrees. So now if I only go a quarter the distance, or 1/4 of pi, this is pi over 4. And if I go pi over 4 again, so that's pi over 4 plus pi over 4 is 2 pi over 4, or this is pi over 2 up here at the 90 degree. So 90 degrees is equal to pi over 2. 45 is pi over 4. We've got 3. This is our third one. 3 pi over 4. Let me write that differently. And then finally, if I add another pi over 4 to that, we get 4 pi over 4, or pi. I could continue on. Let's get some space here. So 225 degrees from the start, from our initial to our terminal angle, is 5 pi over 4 radians. 270 is going to be 3 pi over 2. 315 is going to be, so this is 5 pi over 4. This is essentially 6 pi over 4. So this must be 7 pi over 4. And finally, we're at 8 pi over 4, or 0. Okay? Now say I cut this up into 33 sections. So I have 90 degrees here, and I split it up into 3 equal sections, so that this one is 30 degrees. So this is 30 degrees. That means getting to the next green line is another 30 degrees. This is 60 degrees, and then I add 30 to that, and I get to 90. So I'm splitting this up into 3 equal angles. Well, I can, of course, continue this past 90 in 30 degree increments. So this is 120 degrees, 150 degrees, and add 30 to 150, we get 180 degrees. So again, we've gone pi all around here, but this time I've broken it up into 1, 2, 3, 4, 5, 6. So 180 divided by 6 is 30 degrees, and pi divided by 6 is the increment in radians. So pi over 6 is this first one, 2 pi over 6, or pi over 3 is the second one. If we add another one, we get 3 pi over 6, or pi over 2 again. And then coming over here, if you continue on, this is 2 pi over 3. This one is 5 pi over 6. And again, we get here to pi.